Okay, number 3. It's asking us when liquid bromine is cooled to form a solid, which of the following types of solids would it form? How do you know? So I have liquid bromine, so I have Br, and I have 2 here because this is a diatomic molecule in liquid form. It's going to cool to form a solid. And it's asking us which of the elements could it form here. So I have either, let me do this in a different color. So either atomic, metallic, molecular, ionic, covalent. No. So let me go through these options here. So atomic solids they don't really exist. I don't know what an atomic solid is in the first place. So this is just not an answer. In general, I don't know what atomic is. I don't think it refers to anything. There's no bonding that's being involved here, so that's not correct. Metallic, bromine doesn't have any metallic properties, so we can assume that this here is also not correct. Molecular is possible, so we'll leave that for now. Ionic is not possible because we don't have a cation and ion, so it's not producing any ions, so this is incorrect here. And covalent network is actually not correct as well because covalent network needs I need many bromines to figure that out. An example of a covalent network would be a diamond would be consisted of a covalent network because it's made up of many carbons. So this here is not correct as well. So which means our only answer here has to be molecular. And the reason why here is because we're talking about in terms of Br2, the only intermolecular force that actually exists in Br2 is the London dispersion forces, because bromines here, because they have the same electronegativity, there's no dipoles. So the only thing that existed is the electrostatic attraction between the 2 elements here, which is the London dispersion forces. So this here would be a property of a molecular substance. So the solution here is correct, molecular.